Hi guys, this is O-Level Chemistry, paper 11, November 2017, question 11. The empirical formula of a liquid compound is C2H4O2. Oh, C2H4O. To find the empirical formula, it is necessary to know the density of a compound? No. The percentage composition by mass of the compound? Yes, because in the first step of finding the empirical formula, we divide the percentage composition by the AR of the element. The relative molecular mass of the compound. This should be known if we need to find out the molecular formula after finding out the empirical formula. Otherwise, the empirical formula can be obtained without knowing the molecular mass. And the volume occupied by 1 mole of the compound, this is not necessary in finding out the empirical formula. Therefore, the correct option for this question is option B. Question 12. 25 grams of hydrated copper 2 sulfate crystals are heated to produce anhydrous copper 2 sulfate and water vapor. What is the mass of anhydrous copper 2 sulfate formed? So the MR of hydrated copper 2 sulfate would be 160 plus 18 into 5, which is 90. So 160 plus 90 gives us 250 grams of hydrated copper 2 sulfate, giving us 160 grams of anhydrous copper 2 sulfate. So if we have 25 grams of copper 2 sulfate, what would be the mass of anhydrous copper 2 sulfate produced? So this would be calculated as 25 divided by 250 multiplied by 160, giving us a value of 16 grams, which makes option B the correct option for this question. Question 13. 1 mole of an organic compound Q is completely burnt in oxygen and produces exactly 3 moles of water. Which compound is Q? So in order to find out this compound, we would use the general combustion equation CXHY plus X plus Y upon 4 O2, giving us X CO2 and Y upon 2 H2O. And in this equation, the value of Y would be the number of hydrogen atoms present in our compound. So all we need to do is divide the total number of hydrogen by 2 to obtain the moles of water. So let's start. In butane, we've got 10 hydrogen. So 10 divided by 2 is equal to 5 moles of H2O. In ethanol, we've got 5 and 1, 6. So 6 divided by 2 equals 3 moles of H2O. In propane, we've got 8 hydrogen. So 8 divided by 2 equals 4 moles of H2O. And in propanol, we've got 7 plus 1, 8. So 8 divided by 2 equals 4 moles of H2O. And we need to find exactly 3 moles of water, which is present in ethanol, making option B the correct option for this question. Question 14. Aluminum is produced by the electrolysis of molten aluminum oxide. What is the correct equation for the reaction at the positive electrode? The positive electrode is the anode. Anode is where oxidation takes place. So oxide ion releases 2 moles of electrons to produce oxygen gas. Now, in order to balance this equation, oxide ion will be multiplied by 2 and electrons would in this case now be 4 moles of electrons. So this is the equation taking place at the anode. So A and B are eliminated because they are equations for aluminum. C and D have oxygen. C has reduction taking place because oxygen is gaining electrons, and D has 2 moles of oxide ion producing oxygen gas and releasing 4 moles of electrons, which is the same as the equation that we just wrote. Therefore, option D is the correct option for this question. Question 15. When aqueous copper to sulfate is electrolyzed using copper electrodes, which observations are correct? So, if you are using copper electrode, that means the copper anode would get oxidized and copper cathode would have an increase in mass because copper ions would reduce to form copper metal and deposit on the cathode. So, positive electrode is the anode, the negative electrode is the cathode, and the anode would become smaller. So options A and B will continue. C and D are eliminated. The cathode will have a gain in mass, so electrode becomes bigger. Option B gets eliminated. And intensity of the blue color stays constant because anode is oxidized, producing copper ions, and copper ions are reduced at the cathode. So the flow of copper ions in the solution remains constant. Therefore, option A is the correct option for this question. Question 16. Three different solutions were electrolyzed using inert electrode. Aqueous sodium chloride. So this would produce hydrogen and oxygen gases. Concentrated hydrochloric acid would produce hydrogen and chlorine gases. And dilute sulfuric acid would produce hydrogen and oxygen gases. Which solution produces hydrogen at the negative electrode? So in all three solutions, we have production of hydrogen gas. So this makes option A the correct option for this question. Question 17. Under certain conditions, nitrogen reacts with oxygen to form N2O. The energy profile diagram for this reaction is shown, and this is an endothermic reaction. What is the activation energy for the reverse reaction? So, the activation energy for the reverse reaction would make N2O as the reactant. So, this would be the activation energy for the reverse reaction. So if we have positive 447 as the activation energy for the forward reaction, in the backward reaction, we would have removal of 164 kilojoules per mole of energy because the backward reaction is exothermic. So when we subtract 164 from 447, we are left with positive 283, making option D the correct option for this question. Also, we need to remember that the activation energy, whether it is an endothermic reaction or an exothermic reaction, will always be positive. So with that in mind, options A and B could never have been correct because both of them contain a negative representation for the activation energy being exothermic, which it is not. It is always endothermic, it is always positive. So the calculated value is present in option D. Question 18. The formation of liquid water from hydrogen and oxygen may occur in three stages. In stage one, we've got hydrogen gas and oxygen gas converting into hydrogen atoms and oxygen atoms. So bonds are broken. So this is an endothermic reaction. In two, we've got the atoms of hydrogen and oxygen combining to form steam. So since bonds are being formed, this is an exothermic reaction. And in three, we've got steam condensing to liquid water. The change of state from gas to liquid releases energy, making this step also exothermic. So the question is, which stage is endothermic? So the only stage that is endothermic is stage one, making option B the correct option for this question. Question 19. Sulfur trioxide is produced by the following reaction. Which change in conditions would produce a greater amount of SO3 at equilibrium? So the equilibrium needs to be favored in the forward direction. Adding a catalyst. Adding a catalyst has no effect on the position of the equilibrium. Increasing the pressure. So increasing the pressure will favor the side with the lesser number of moles. We have got 3 moles of reactants and 2 moles of products. So increasing the pressure will shift the equilibrium towards the right. Increasing the temperature will favor the endothermic side of the reaction. Since the forward reaction is exothermic, increasing the temperature will shift the equilibrium backwards. And removing some SO2 and O2, which are reactants. So if we decrease the concentration of the reactants, the equilibrium will shift towards the left in order to restore the concentration of the reactant. Therefore, the only option in which the equilibrium is favored in the forward direction is option B, making B the correct option for this question. Question 20. A chemist investigated the rate of the reaction between ethene and hydrogen using a nickel catalyst. The chemist carried out 3 experiments under different conditions. Experiment 1, the pressure was 1 atmosphere and the particle size of the catalyst was powdered. In 2, the pressure was 0.5 and the particle size was powdered. And in 3, the pressure was 1 atmosphere and the particle size was large pieces. Which row is correct? Comparison of rates of experiments 1 and 2. So since the pressure is less in experiment 2, so the rate of reaction would be slower in experiment 2. So the rate of reaction of experiment 1 is greater than experiment 2. So 1 greater than 2 is the option present in A and B, eliminating options C and D. And the next column says comparison of the rate of experiments 1 and 3. In 1, we've got powdered particles of catalyst, and in 3, we've got large pieces. So the powdered particle would increase the exposed surface area, thereby increasing the rate of reaction. So we have the powdered variant of the experiment, which is experiment 1, giving a greater rate than experiment 3. So in option A, we've got 1 greater than 3, which is correct. In B, we've got 3 greater than 1, which is incorrect, eliminating option B, making option A the correct option for this question.